Solution stoichiometry. So now we can do a variation on the stoichiometry that we learned in chapter 4. Here we've got amount of A in moles to amount of B in moles, and that's what we're going to see in all stoichiometry problems. So what I taught you was grams to moles to grams. But for a variation, we can change up the first unit or change up the last unit, or we can change both of them. So we could make this a volume in liters, and we could find the grams. Or we could start with the volume in liters and end up with the volume in liters. So you always start with grams to moles to grams, and then you just change the ends as needed. So what volume in milliliters of a 0.150 molar nitric acid solution will completely react with 35.7 milliliters of a 0.108 molar sodium carbonate solution according to the following balanced chemical equation? Well, let's find the numbers. Here we've got 0.150 molar HNO3, 35.7 milliliters of 0.108 molar sodium carbonate. And what do we want? Volume in milliliters. This is stoichiometry, and so you can use the equation to help organize things. So 0.150 molar nitric acid. So under nitric acid, wherever it happens to be, I'm going to write its concentration, 0.150 moles per liter. And then this is 35.7 milliliters of this guy, that's the sodium carbonate. So I have 35.7 milliliters of that, and they tell me its concentration is 0.108 moles per liter. And I am trying to find the volume in milliliters of that guy. So stoichiometry, you start with grams to moles to grams. But we're not starting with grams. We're starting with a volume. Remember these per units, those are going to be conversion factors. This per that. This is a start. And at the end, we want milliliters. So I'm going to start with the milliliters of the thing they told me the most about. 35.7 milliliters of Na2CO3. And I'm going to go to moles of that. I'm following this path up here. It's kind of sketchy, but it's good enough. And then I'm going to go to moles of the other thing. And then I'm going to go to milliliters. So just off the top of my head, I think very quickly of 3 different ways to deal with the milli part. Well, we'll try millimoles. So we're just going to go in here. So down here, we're supposed to bring this unit, and we see we kind of have a problem. Of course, you can convert that to liters, but then at the end, you're going to have to convert back. I wrote that in the wrong place. I thought that looked funny. That belongs over there. Moles of Na2CO3 and moles of HNO3. Let's think about a fraction. 1 over 2. If I multiply this by the same thing on the top and the bottom, I get 2 over 4. Is 2/4 different than 1/2? No. What I can do here is, instead of, I usually would have moles per liter. I can stick a milli up there, millimoles per milliliter. So this 0.15 millimoles per milliliter, and the millis would cancel out, right? So really, this is the same as that. Does anybody have a problem with that? This is a concept, the millimole, that I've had a hard time getting students to understand. But I think you guys are going to be the class that gets it, right? So millimoles over milliliters. And I could do the same thing to this one, right? Millimoles over milliliters. So the sodium carbonate is right here, and that's supposed to be 0.108 moles per liter. But if we canceled those guys out, that's what we have, right? We just put those in there because this is going to work out so nicely to cancel milliliters here. At the other end, we have moles, and milliliters. Let's make that millimoles and milliliters, and that's this 0.15. 0.150 millimoles per 1 milliliter. We just made everything smaller. The ratio is the same. Here in the middle, what's the mole ratio from the balanced chemical equation? Yeah, it's 1 sodium carbonate for every 2 nitric acids. So 2 moles of nitric acid for every 1 mole of sodium carbonate. I could also write 2 millimoles per 1 millimole. And now my units are going to work out. So now I can do the calculation. 35.7 times 0.108 times 2 divided by 0.15 equals 51.408. Milliliters of nitric acid. And that should have 3 significant figures, so 51.4 milliliters. This milliliter thing and moles per liter comes up a lot because usually we're talking about relatively small quantities, less than a liter, and so the volume is measured in milliliters, but the molarity is always moles per liter. And so you can use millimole as a shortcut to avoid a bunch of unit conversions. Any questions? (51.4). Consider this reaction. This is conceptual, so we're not supposed to have to do any calculating. We got 2 moles of A reacting with 1 mole of B to make 1 mole of C. What is the limiting reactant if you mix equal volumes of a 1 molar solution of A and a 1 molar solution of B? A will be the limiting reactant because you need twice as much. Their concentrations are the same, so whatever the volume is, if they're equal, you have an equal number of moles, right? But you need twice as many of A as you do of B. So that means you're going to run out of A first. And A is the limiting reactant. Any questions?